Okay, so let's try this question. This question is based on method of same potential. Try to label each point potential and you have to calculate between the point A and B. So question is to find C equivalent between A and B. Okay, try this. What is the answer? Hmm? Any answer? Hmm. Hmm. 2 by 3C. Okay, let us check that. So I want to calculate between A and B, so I will label all these points are same points A. All these points are same points BB. Same point, same point, same point. Let us take this point, this is a different point, let us take this point as P. So all these points are same PP. Now we want between A and B, so let us take these points A and B, and P is a some point somewhere we do not know. So if you do not know point P anywhere, you can draw. Let us take point P is here. So we can try to now connect capacitors. So if you see this first capacitor is in between A and B, this capacitor, uh, okay, there is only one capacitor in between A and B. A and B is having only one capacitor. P I will put here. So in between A and B, let us draw this capacitor. One capacitor, this capacitor is in between A and B, this I have drawn. Then this is in between P and B. This is also in between P and B. So two capacitors are in between P and B. So P and B, two capacitors. So one is like this, another is like this. Right, two capacitors I have drawn. So this one and this one I have drawn. Now remaining this one. In between A and P, one capacitor. So one capacitor. Done. We have drawn all the capacitors now, and we have to find in between A and B. So slowly you try to make equivalent. So we can clearly see that here these two are in parallel. So C become, C plus C in parallel, 2C it will become. So in between P and B, you can write now as 2C, and in between A and P there is already one C, and there is another C here bottom. Now you can clearly see that 2C and C, they are in series. So their equivalent will be 2 by 3, right? So now I will reduce further. The upper branch will have 2 by 3C. Lower branch is still having 1C, right? Okay, now they are in parallel. They are in parallel, correct? So if they are in parallel, let us do the calculation of parallel. So final R equivalent is 2 by 3C plus C. So it will become 5C by 3. Are you clear about this? So where did you make mistake? Can you figure out? Huh? You got 2, 3 by C, but last step you did not add C. So these type of mistakes can happen, right? So you take care of these mistakes. Okay, let us try to do few more questions on this method. One question is like this: 1, 2, 3, 4, 5, 6 capacitors are there. Each capacitance is C, 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 C. And it is given that this is connected here, this is connected, this then is going here. Okay, so question is find equivalent between this point A and this point B. Try. Now this time you can try this and take care of your mistake. What is the answer? How much? Try. Yes. What is the answer? No? How much? Why so much time? Immediately you can solve it. What is the problem? This point is A. This is also A. This is also A. All these points are A. 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 This point you have taken B. So that's okay. If I take this point as P, then these are all P. 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 That's all. Any other points is left out? This point we have mentioned. This also okay. This is left out. Let us take this as Q. This point is Q. That's all. All points you have labeled it. Now try to redraw the circuit. Redraw in between A and B, and there are two extra points. Two extra points are P and Q. You don't know, you keep somewhere. Okay. So what this point is A and this point is B. And there are some two different points P and Q. So P will be P and Q somewhere, we have to keep it. Okay, if you don't know, let it keep here P and here Q. And now try to connect capacitors. Try to connect capacitors. So first capacitor A and P. Now see this one, this capacitor is in between A and P. This capacitor is in between A and P. What about this capacitor? This capacitor. This is also in between A and P. This capacitor is also in between A and P. So three capacitors are coming in between A and P. So in between A and P there are three capacitors. 1, 2, 3. Okay, three capacitors are over. Then one capacitor is in between P and Q. This one. This is also in between P and Q. So two capacitors are in between P and Q. Okay. Then last capacitor is in between P and B it is. Not Q and B. P and B it is. P and B it is. Okay. That's all. Nice. So we want between A and B. You want equivalent between A and B. Sure. Suppose if you connect with a battery, this you connect with a battery. So some plus minus, V voltage. So this charge, positive terminal will supply some charge, it will get equally distributed, or it will get distributed on this capacitor. But then here at this point you see the charge can try to break into these two components and these three components, but here there is no connection is there. Note that this point Q is not at all connected with any other point. This point Q is like a open circuit. So this point Q is like a open circuit because it is not connected with battery. So charge will only flow from this side to this side only wherever connection is there with battery. This side is not connected, so charge will not flow. So you have to now note that this portion is going to become redundant. You can just remove this, in between P and Q, these two parallel capacitors can be removed. So now what do you get? Now you get 3 CCC, right? CCC in parallel will give 3C, and then there's only this C. So this 3C and C are in series. Over, game is over. So C equivalent will become 3 by 4C. That is the answer. Okay. Are you understanding this? So now what is, you have to understand that these two capacitor has become redundant because of open circuit. Okay. So two capacitors which are in between P and Q, they become redundant. It is called redundant. Redundant. Redundant means they are not useful for the circuit, so we can remove them. Now it's a very important thing to understand when can capacitor become redundant or useless in a circuit. So this is one case where if there is some open circuit happens, some capacitors which are like open circuit, there is no connection with battery, they will become redundant. Okay, and there can be another case where it can become redundant. That is what? That will be like a short circuit case. Let us try to understand that. So open circuit case they become redundant, and one case more short circuit can also happen. Let us try to understand this case. Suppose there is one capacitor, another capacitor, and let us say that I connect this with battery, and I connect like this one, and I also connect with this one. Okay, so battery voltage is V. So if I want to calculate between A and B, what is the equivalent? Battery is connected like this. So note that this point, all these points are A. This side point I am taking as B. So these are all B. Note that here also this is going to be B only, right? Because all these are connected directly without anything. So they are all B. Now if you try to redraw this circuit, Try to redraw the circuit. In this case, you want in between A and B capacitance. So this is point A, this is point B. Okay. If you try to connect capacitor, this first capacitor, this capacitor is in between A and B, right? So in between A and B, you can connect. But this capacitor is in between B and B. What does that means? It is connected between the same point. That means you may try to connect it some capacitance. You can connect it like this. You can connect it like this. But the battery which you have to connect, B and B means this is also B only. But the battery which you have to connect battery in between A and B like this. Battery you have to connect in between A and B. So now if battery has to supply charges, right? So how battery will supply charge? Suppose this positive terminal will supply some charge. This charge will go here, plus Q minus Q, and same charge has to come back. So the same charge has to come back here. That charge will not go into this branch, right? Charge has to directly come here, and there is no potential difference between them because they are same point B and B. So if their potentials are same, the potential difference becomes 0, and charge is equal to C into potential difference. So potential difference is 0, so here 0 charge will be there. No charge will be there here. Okay, that is why all the charge will be only appearing on this plus Q minus Q, and then it will be coming in this battery. Okay, so here in this case you can see that this portion is going to become redundant. This has become redundant. Redundant. So this is the case where it is short circuit. Okay, short circuit. So if two capacitors, if the potential difference is 0 between them, that means they are short circuit, and that capacitor will become redundant. Like here, it was open circuit and it has become redundant. So for these two cases, capacitor will become redundant either in open circuit or in closed circuit. Are you clear about this? Yes? Okay, done. So I think you can work out problems like that. Okay, then let us move next. Method of Kirchhoff law we have discussed. If you remember, Kirchhoff law is a very important tool. You can work out any level of question using Kirchhoff's law. But the only thing is that you should know how to use it properly. Okay, so I'll give brief review about that, and we can see some questions on that Kirchhoff's. So you can say that this is the method number 2, method of Kirchhoff's law. Method of Kirchhoff's law. So basically there are two rules are there in this. What are those two rules? First is called voltage rule or loop rule, and second is called charge rule. Okay, or junction rule. Junction rule. So this is based on energy conservation. And this rule is based on charge conservation. Okay, these are two things. So now how to apply voltage rule? Let us try to understand that. Suppose that there is a circuit. Okay, there is a circuit and there may be more capacitance. Let us say that, and there is a battery here. Battery voltage is V, this is plus minus, this capacitance is C1, this capacitance C2, and you can again label them. Suppose this point is A, this point is B, this point is C, this is same point C, and then this is A, right? So this is one loop. Now here, what does this law says? That this law says that the sum of all the change of potential change across each element is going to be 0. This is simple, meaning of this rule. Change of potential, right? Sum of all the change of potential. So that means, suppose if I am going A to B, B to C, and again coming back to A, then you are going in a loop. You are moving in a loop. So when you are going in a loop, remember this is only true in a loop. In a loop. In a loop, sum of change of potential is going to be 0. So here what does that mean? Suppose you are going from A to B, B to C, again coming back to A. That means potential difference between A to B plus change of potential between B to C plus change of potential between C to A is going to be 0. Okay, this. So how this is going to be 0? And why this is going to be 0? Because if you take a small charge and move in a loop, remember, work done in a loop is 0 for conservative forces. You have studied that, yes? Work done in a loop for conservative forces. So work done in a loop is 0 for conservative forces. So here you can take any small charge or any electron which is going in a loop, coming back to the same point. Work done on that will be 0. So work done, how do you write work done? Work done is a small charge into potential difference. Remember now, work done is the charge into potential difference, and this has to be 0. So sum of all the potential differences are 0. Right, so that's what it is. It is the sum of all the potential. Delta V here refers to sum of all the potential in a loop. This is potential difference in a loop. So that's what it is. When I am writing VAB, that what does that means? VAB means potential of B minus potential of A, because you are going from A to B, right? So when you are writing this, that means potential of B minus potential of A. Plus similarly, when you are writing VBC means potential of C minus potential of B. Similarly, when you are writing potential difference CA means potential of C minus C to A you are going, right? So final point is A. So VA minus VC. This sum is anyway 0. You can see that why it is 0, because this minus VA plus VA cancel, plus VC minus VC cancel, minus everything cancels out, and it will become 0, because for conservative forces this is true. And now suppose if you have to write the delta VAB, how will you write it? Note here. Suppose if I want to write delta VAB. So delta VAB, how I will write? And same charge remains in series. Charge remains same in series. But when you are going from here to A to B, note that you are going from positive terminal to negative terminal. So when you move from higher voltage to lower voltage, change of voltage is negative. So you will write this as negative, and voltage difference is Q by C. You know that. Similarly, when you go from B to C, so here also you are going from higher to lower voltage. So potential difference B to C you can write as minus Q by, this was C1, Q by C2, right? Minus Q by C1 minus Q. And if you have to write C to A, how will you write potential difference of C to A? C to A, you are going from negative terminal to positive terminal. That means you are going from lower voltage to higher voltage. So the change will be positive, and this voltage difference is the battery voltage. So it is plus V. Now you can substitute in this equation and you can solve whatever you want to solve. Are you clear about this? Yes? Okay, so you have already done. Then what about the charge rule? Charge rule you will be applying, whenever there are some branches happens. Suppose there is a branching happening in this capacitor and this capacitor, and then let us say it is connected with a battery, plus minus. So what will happen here? Some charge will go from positive terminal of the battery. This charge at this junction, at this point, this charge will split into the upper branch and lower branch. This charge is plus Q1 and this is plus Q2. So here if it is plus, this side will be minus. Here it is plus, then this side will be minus. And finally the same minus Q charge again will combine here and it will give us the same charge. So like that you can do. That means here Q will be breaking into Q1 plus Q2. So Q equal to Q1 plus Q2. Like this you can do. This is what is charge rule. Okay. Then you can solve a lot of questions are there. Lot of questions will be there on this. Okay. So let us try to see some questions. Let us take this question now. Let us work out some problems. Three microfarad. This point is P. 4 microfarad. 2 microfarad. This point is B. They have given a potential of this. So here point A has potential of plus 1200 volt, and they are asking find potential at P. That is the question. How are we going to solve problems like this? Okay, it's a very important that you learn this very strongly, so that never there can be any confusion. Okay, there cannot be any confusion, because Kirchhoff law is the basic, fundamental. If you know, you can solve any type of question. Of course, some question may be lengthy to solve, but this can be applied to any type of circuit. Okay, how to solve this? Let us try to understand. So we want potential here. Okay, potential here. So you do not know what is on. One important thing is that this point is ground, means it has 0 volt. This point which is ground now, that means it's like a 0 volt. Okay. Then how can we take it? This is 1200 volt. This voltage we do not know, that is 0 volt. Okay. So what you can do is, let us say that potential of this point is x volt. X volt is the potential of this point which you want to calculate. You can write this as x. Now what you can do is, now you can think about the charges. Let us say that I keep here charges plus q, and I'll keep a charge of minus q here. And note that means I am considering charge is flowing like this. This may be connected with a battery and charge is flowing like this. And this charge must be breaking here. So here some charge plus q1 must be there and minus q1, and here charge will be plus q2 and minus q2. And note that q is equal to q1 plus q2. This I have applied the charge rule. Why it is? Because note that, also note one important reason, that this plate and this plate and this plate, these three plates you can see, they are not connected with any battery, because when you connect a battery, you can connect battery here only. You can connect on the ends which are free this side, right? So there is a battery connect, because there is a potential difference of 1200 volt and 0 volt. So potential difference is 1200 volt between A and B. So you can assume that there is a battery of 1200 volt connected between A and B. You can assume it. There is no mistake in that, because there is a potential difference of 1200 volt. So if battery will supply charges, it will split like this. And note that these three plates are not connected with battery. The charges will be only due to induction, and the sum of all the charges will be 0, right? So here minus q, there will be plus q2. So sum of all charges, that means minus q plus q1 plus q2 is 0. This is what is this equation. It's a basically charge conservation, right? Okay, then now we know this rule. Now you can go in a loop. What loop can we go? What loop can we go? Let us try to make a loop. Loop may not exist, but you can make a loop. How can you make a loop? You imagine that there is a loop between A and this, right? You imagine. Loop may not exist, but you can imagine. Imagination has no limitation. You can imagine anything. Okay, so imagine that there is a and O is connected, like just like a battery is there. So it is like a loop is there. Okay, then now you go in the loop and try to apply this loop. Suppose, first of all, suppose I can go in this loop also. There is a loop here, you can see that. There is a loop here, and you can see that these two capacitors are in parallel. Can you see that these two capacitors are in parallel? Yes. Okay, if the capacitors are parallel means potential difference are same. So whatever the potential difference, that potential difference will be V equal to Q by C. So on the above Q1 by C is 4 and below Q2 C is 2. So that means you can get that Q1 is equal to 2Q2. So one idea we got. We need one more equation relation between charges, right? How to calculate, that is what we can start moving in this loop. So let us try to move in this loop. Okay, suppose I go from A to P. A to P, if I go, the change of potential will be how much? Minus Q by 3. Change of potential, right? Minus Q by 3. Then let us go for any of the upper or lower, anything you can go. So change of potential will be what? Change of potential, you are going from higher to lower. So again change will be minus. And you are going from here to here. So it will be, suppose I go upper branch. So upper branch I can take Q1 by capacitance is 4. Then after coming here I will cross from this to this point. So again, because I have to go in a loop, right? We need to go in a loop. So let us go from this 0 volt to A. So change of potential will be 1200. So plus 1200 is equal to 0. So now can we solve that? Can we solve? So first of all, see here Q is equal to Q1 plus Q2. Q1 is 2 times of Q2. So 2Q2 plus Q2 become 3Q2, right? So we can definitely have this idea. That means Q can be converted into Q2. Q1 can also be converted into Q2. Now let us calculate Q2 first. So from here, that this terms I will take that side. So Q by 3, Q is 3Q2 by 3 plus Q1, Q1 is 2Q2 by 4 is equal to 1200. So from here 3 get cancelled, 2 get cancelled, right? So Q2 plus 3 by 2 Q2. So what will be Q2? Q2 will be 2 by 3 of 1200. 2 by 3 of 1200 will be how much? 2 by 3, 12 into 2, 2400 by 3. 2400 by 3 will be how much? 2400 by 3 means 800. Correct? So Q2 is 800. So Q1 is, now we can understand, if Q2 you got, so Q1 also you got. Because Q1 is double. It becomes 1600. And capital Q is 3 times of Q2, so that is 2400. Okay, so now all these are in microcoulomb. Okay, all the charges, because units are microfarad, microcoulomb. Okay, so once you get this charge, now you tell me potential difference between potential difference means change of potential. So you can take higher minus lower. So potential at A, which is 1200, minus potential at P, which is X. We have taken this potential is equal to Q by C. So here charge is how much? 2400 by capacitance is how much? 3. So from here what will be X? Tell me. How much X will be? Because this become 800, right? So 1200 minus 800 become 400. 400 volt, that is the answer. Are you clear about this? It is looking lengthy, but by practice it will come gradually. Slowly, slowly, you have to practice a lot of questions in this. Then only you will be, able to get that idea. Okay. So your next exam is tomorrow. Friday is there. What are the portions? I'll check that. Electric potential and capacitance. So capacitance, I think methods of finding equivalent, only other things we have already done that, right? Methods of potential calculations are there. Lot of methods are there, but these are the most fundamental methods. Okay. Then what are other methods? So Kirchhoff's law method we can apply to solve any type of problems. Method of same potential. Then let us say method of balanced Wheatstone bridge. Balanced Wheatstone bridge. Derivation will do next class, but right now let us note that method of balanced Wheatstone bridge. So Wheatstone bridge is made up of these 5 capacitors like this. This is point A, B, this is point C, D. This capacitor is 1, this capacitor is 2, this capacitor is 3, this capacitor is 4. This middle one you take as 5. So the arrangement of this 5 capacitor, it is called Wheatstone bridge. And balanced means what? Balanced means what? What is meant by balanced? Balanced Wheatstone. Balanced Wheatstone. Balanced Wheatstone bridge means that there is no charge in the middle branch. No charge in C5. That means C5 has become redundant. Try to understand, C5 has become redundant. Okay. C5 has become redundant. C5 has become redundant. So the potential difference across, see, redundant always does not mean short circuit, or it doesn't mean always open circuit. Okay, note that there are two ways it become redundant, either short circuit or open circuit. But here, whether it is short or open, how do we know that? So note that here if you say that there is no charge, this is an important thing when we are saying that there is no charge. If no charge is there, then potential difference becomes 0. That means potential difference of CD is 0, right? That means potential of C is same as potential of D. So there is no difference of voltage between these C and D points. Okay, that is what it is. So we cannot exactly say like they are short circuit, but it doesn't look like short circuit. Okay, but you can assume that whatever the point, this potential, same point it will be. Okay, right. So what happens now? How can we do calculation? Because if this is redundant, you can remove that, and if you remove it, then what happens? Then you can just see that upper two capacitor and lower two capacitor has become parallel, because this C1, C2, C3, C4 is there. C5 is removed, so it becomes very easy because upper two becomes series. So C1 C3 by C1 plus C3. Lower 2 becomes series C2 C4 by C2 plus C4. And then final C equivalent is parallel. So C equivalent finally you will get C1 C3 by C1 plus C3 plus C2 C4 by C2 plus C4. Like this you can get. But the question is when it will become redundant. What is the condition for redundancy of the middle branch? So for middle branch to become redundant, the condition is if the ratio of C1, C2 and C3, C4, if these ratios are equal, then only it is balanced. Then only it is balanced. Otherwise, it will become unbalanced Wheatstone bridge. Are you clear about this? Right? So that's what for today. Unbalanced, how to solve? We can solve by Kirchhoff's rule. We can solve, and there are star delta methods are there that we will be discussing next classes. But till now, you can start working out problems on capacitors, series combination, parallel combinations, method of same potential, Kirchhoff's law, balance Wheatstone bridge. These methods are sufficient to solve many varieties of problems. Okay. I will be sending the worksheet and then you can start problems. Okay. Fine. Okay, then we'll see next class. Bye bye.